Yeah. So if you take any high-level programming language, right? So if you
And
look
they start from binary one, no? So actually, you use some important words so that when we are seeing it, we can make a notes.
okay, good. Okay. So binary is nothing but uh, so
Machine language.
yeah. So obviously, if you look at from a product life cycle, right? So what will be having? You will be developers will be writing the code and they will be pushing the code to the code repository. So from code repository, a continuous integration tool like Jenkins, it will pull the code from code repository, it will compile, and it will generate an artifact. Okay. So what exactly meant by an artifact? Artifact is nothing but it could be anything. Like so, it could be a jar, it could be a var, it could be an exe, it could be an RPM. Even sometimes it could be a zip file or it could be a text file, even it could be a PDF file, whatever it may be, it could be a movie file. We can call anything as an artifact. But from a product life cycle, most of the times, here an artifact means it is a binary. So what exactly binary? How you will get a binary? So binary is nothing but, so obviously when you are developing a product, right? You'll use some technology to implement that product or to develop the product. Or there could be multiple technologies, right? So maybe if you are developing a Java-based application, you'll have a front end, something like web UI, right? You'll have a back end logic Java, right? So you might be resulted in JavaScript and Java programming language, or sometimes you may integrate some code with the Python, whatever it may be. So that all technologies, we call it as a high level language. We write in a high level language. So from high level language, then you need to convert that high level language, compile, and that compiler will convert that high level language into a low level language, which is nothing but a machine language, which is again in turn nothing but binary, zeros and ones, right? So if you come from computer science background, obviously you might have studied the topic compilers. So what is the purpose of a compiler? Compiler takes the high level programming language, the source program, and it will compile and convert this high level programming language into a low level programming language called machine language or a binary. Okay. So this is a machine language or a binary, right? In this process, it may use some dependencies, right? So those dependencies, what we call it as, we call as, we call them as libraries, right? So libraries are nothing but, so if you wanted to start a program, if you wanted to develop a program, for example, you have developed a program to connect to a database, right? And you have developed a database driver. Every time whenever some programmer is writing a program to connect to a database, does he need to develop the database driver all from the beginning? Not required, right? Someone has already developed and it is already available for me. So I can directly use, right? My aim is not to develop a database driver, right? My aim is something. I wanted to develop some application, which in turn I'll use some database. So my program should be able to connect to the database. In that process, these database drivers are needed. So altogether, I can develop database drivers, or if someone might have already developed those database driver programs, and I can directly use them. So this is just an example I'm telling. Not only database drivers, it could be anything, even some printf statement, right? Someone might have to write a code to printf statement, right? Even that is also a code. So I can use that simple library or function from that printf statement, and I can use it here. Or I can write a logic to printf the statement, right? So for me, I have to just give an information on the screen to print something. For that purpose, I don't need to spend time to write all together the printf logic, right? Printf logic is already developed by someone. Why should I waste, right? So the main purpose of the software itself, you understand, any object in this world or any article, for example, you take soap, right? What kind of material it is? When you use it, after some time it will use it will lose its life. That means it cannot be, I mean, it will vanish, right? But if in case of software, you write it once, use it many times, right? Many places. Even you use it for thousands and hundreds and lakhs of times, It will not lose its shape or it will not lose its functionality. So that is the advantage of software. So you write software once and you can use it anywhere, anytime, right? Provided you have the rights to use it, right? So that's where these libraries will help you in, reusing software. Okay. So now again, coming back to the source program. So for example, it is, I have written a hello world Java program, right? So this hello world Java program will have a what? Java compiler will be there. We call it as a Java C, right? This Java C will compile this hello world.java and store it as a hello world.class. So this class file, .class file is nothing but your bytecode or binary or machine readable language. So will there be only one program, hello world.java? No, right? There could be huge number of files, right? I might have hello world.java, dbconnect.java, user information.java, some XYZ. So many files will be there. All these files will be compiled. And as part of one functionality, maybe user data, there could be huge number of files. For that reason, what I could do, I'll be resulted in so many class files. What I can do, I'll compile or I will group all those class files into one package. Okay. Here package is nothing but archive, right? So I can archive them. So that archive name you can name, because if it is a Java program, you can name it as jar. Okay. Jar means Java archive. Or it could be something, if your application is a web-based application, then it is where. Where means web archive. Okay. For example, if it is something else like enterprise related application, it is EAR. Okay. EAR means enterprise archive. What is this jar, where, EAR? And this is because Java, and it is a platform independent language. The nomenclature would be something like this. Package format would be something like jar, var, EAR. For example, if it is something Linux based application, again depending on platform, it could be RPM, right? Or it could be Debian package .deb, okay? Or it could be NPM, or it could be NuGet, it could be exe. What are all these? Or it could be MSI, right? It could be DMG. Yes, have you ever heard or seen these packaging types or formats?
Yes.
If you wanted to install something in Linux, they use RPM. And even in Linux, if it is a Debian based format like Ubuntu, it is .deb. And if it is a NPM based projects, it could be .npm or NuGet, right? So if it is a Windows based application, it could be exe, MSI, right? And for Mac, it could be DMG. These are all packaging formats or packaging types. This packaging format or type will change based on the operating system or the kind of project that you are building. If it is a Java based project, irrespective of whether it is a Linux or Ubuntu or Windows or Mac, the packaging format could be jar, var, EAR. Sometimes it could be simply a txt file or zip file. Okay. Or again, we have in zip so many zip formats, right? 7z or tar file, right? So this could be anything. This is what we call it as an artifact. So artifact is nothing but it is the outcome of a successful build. When you compile or when you build your source code, will result in an outcome. That outcome we call it as an artifact. Okay. So artifact is nothing but it has so many meanings. Artifact is nothing but an executable item or an installable item like MSI or RPM, right? Or simply it could be a zip or tar file or something like jar or wrap. Okay. So altogether it is an installable item. Okay. So when you will get it, an artifact, so artifact most of the times is resultant of a successful build. If the build fails, you still get an artifact.
No.
You don't, right? So your code is compiled successfully, and if the build is successful, then only will result in an artifact. Okay. Then this artifact should have some properties, right? What are the properties or attributes of an artifact? So artifact will have some attributes called, we call it as a GAV. Okay. G means group ID. Okay. And A means artifact. And V means each artifact will have option, right? So we call it as a GAV properties. Along with this thing, we have also packaging type, what kind of package it is. Example, if you search in the internet, you will have so many times com dot. I think you might have seen while downloading or referring some packages. Take any example of any palm dot file. You'll see something like com dot, okay, apache dot, um, um, maven, or I'm just giving an example. So what is this? This is a group ID. Okay. And after that one, you'll have some artifact name. And after that one, you'll have some 1.7.1.jar. Okay. This 1.7.1 is a version. Jar is a packaging type. And this is an artifact name. And this is a group ID. So each artifact will have a unique name. So why we need to have a unique labeling for this thing? Why?
And the code requires it needs to load any particular dependencies.
Yes. So when you wanted to use this, either in any programming language or when you are writing some other programming, you wanted to use this as a library, then you should be able to easily map this from where it has to download, what is the name of that package, right? And also if you wanted to install anywhere, you need to have the specific name. Okay. So you might have a location uh, where you can go and download from. In that case, you should be easily locate that one, right? So what is the latest version also? Maybe if you have a naming like this, 1.7.1.jar or 1.8.2, then obviously with that naming convention, you could understand that, okay, 1.8.2 is my latest code, then 1.7.1. And each release, you can mention in the release notes what are the changes it was, that contains, right? What are the dependencies? All these things also you can club it with the documentation. Okay, but the majorly the nomenclature or this labeling helps you in identifying which is the right package for you, which is the target package that you wanted to download. Okay, so these are the properties of any artifact. Okay.
So Ali, artifact is nothing but a file which can be installable and which can be executable.
Yes, yes, that's it. Simple, right?
Yeah.
If you go to Java site, right, or you sometimes often download. Okay, I wanted to download JDK, right? My computer is dead slow. Okay. So you look at here, right? So if you see, if you wanted to install this Java on Linux, right? It has this location from where you can download. And you could see the same thing what I was trying to say, right? JDK -19 underscore Linux ARK64 underscore bin. This is the package Artifactory, because while with the name also you can easily identify for which platform this package can be downloaded. If your machine is a 64-bit architecture, right? And you wanted to simply download the tar file and extract, and that's how you wanted to use the Java. This is the package. Or you wanted to install it through with the help of RPM, RPM-IVH JDK 19 Linux ARC64. Then you can download this thing. Okay, and this is x64 compressed. This is ARM processor. This is for Intel processor. Okay, again based on what processor your computer contains, so you can download that package. If yours is a Ubuntu kind of thing, right? So then it is .deb package, right? So you have easily you can know distinguish between what is the right package for you. Simply this is an artifact. JDK-19 underscore Linux x64 bin RPM is also a package. This is also a artifact. This is also an artifact. This is also an artifact. Whatever it may be, the thing that which you can install on your machine. If you see the Mac OS, right? For Mac, the binary format is DMG. Still, you can go ahead and download the archive format or zip files and extract it onto the local machine. And if it is a Windows based, right? You have zip, exe, and MSI. Based on the platform, the packaging type will change. Okay, the name of the artifact will also change, but altogether the main major version is JDK-19 is Java 19. What you wanted to download. For example, you wanted to download Java 17, right? Again, you see the naming convention JDK-17, right? Again, the packaging type will change based on the operating system. This is nothing but simply an artifact. Artifact is the item which you can install on end machine or target machine. Okay. So now the beautiful concept comes into picture here. How do you get this URL? How you could, because Java has developed something and they have uploaded these packages, right? So that's how you get a URL here. Or else, if they have compiled and stored this artifact somewhere in their computers, so how do you access it? Will you be able to access them? No, right? So there should be a way. So if I have this URL, I can even use it in programming language. For example, I am writing a shell script. I can simply write wget and this URL or call this URL. This will download, right? So I can make that in a shell program, or I can use a REST API, whatever it may be. During the automation, I can directly download, or if I'm writing an Ansible program, I can give the source URL from where it has to download. It will download and install for me. For me, no need to do any manual thing, right? So when you have an artifact repository, so this Java behind this web page, and because you how you are getting this thing, so the download.oracle.com, this is stored somewhere in their Artifactory. That's why you got this URL. Okay. So even for any organization, if someone has to expose their artifacts to the public or within the organization, you need an artifact repository. Okay, you need an artifact repository. So what do you mean by an artifact? What do you mean by a repository? First of all, a repository,
it's a place storage.
Yeah, you store something, store your files, right? We have two kinds of till now you have learned about only one kind of repository. What is that repository? You all learned about Git repository, source code repository. Okay, Git is a source code repository. In Git, you can see all the code, right? If you click on your web GitHub account and see what is the content of that file, what are the changes, everything, it is a human readable format, right? That is a source code repository. But whereas this one, what is there? If you click on this RPM file and you try to open this thing, what will you see? Simply zeros and ones are the format which you can never understand. So this is that is a source code repository, and this is a binary repository or artifact repository. That is the major difference. Again, if you can recollect again my previous diagram, right? Source code will be compiled by a compiler, and the compiler will generate a binary, right? So that source code will be stored in the source code repository. This binary will be stored in the binary repository, right? So that is nothing but an artifact repository. Clear, right? So two more diagrams comes into picture, right? This is your source program, right? This is your compiler, right? This is your binary code or machine language, which is an outcome of a successful compilation or successful build, right? And from where you got this source program, you have this source code repository, something like Git. And where you are going to store this binary, an artifact repository, something like Jfrog, right? So this is an artifact repository. And this is your source code repository. So the major difference is source code repository, what is there in each file, it is a human readable format. And here, this is not a human readable format. Clear? Okay.
What's the last one?
Jfrog.
Oh.
So this is a kind of, and we have various tools, okay, in this space. Artifact repository. We have Nexus. I can teach any of these things. Okay. We have Jfrog. And Jfrog is most popular nowadays, but still most of the organizations are using Nexus as well. Nexus, most of the times it is a open source and free. Even some commercial version is there, but most of the features are exposed in open source as well. Whereas Jfrog is, even it comes with both the version, so open source and commercial version. But the good features are there with the commercial thing only. Okay. Now we'll learn how to install. This is a very simple topic. I mean, not too much no complicated thing to understand, or no need to spend much time on this topic, right? Straight away we'll install Jfrog, configure Jfrog, and we'll see how to publish, right? Once you compile a program, and we have seen till this thing, right, in our previous classes. So we have pulled source code from Git, and with the help of Jenkins, right, we could generate this at binaries, and but the binaries are stored where? On the same Jenkins machine, right? Now our aim is to push this Jenkins, the artifacts which are generated by Jenkins to a artifact repository, something like Jfrog, right? So till this we have completed. Now we're gonna learn this. Okay. Yeah. So for this again, this Jfrog is also a Java-based application. So when you have, if it is a Java-based application, what exactly you need to have? First of all, you need to install Java. Then on top of that one, you need to install Jfrog. Okay. First you need to install Java, then install Jfrog. Same thing, whatever we have done for Jenkins. First we have installed Java, then Jenkins. Here, first we need to install Java, then Jfrog. Okay. We need a computer for this. Can anyone help me with?
Yeah, I can do.
Arvind, you are giving computer to me? Or not Arvind, Vinod?
Yeah, I said yes, but you're silent, so I'm waiting for you.
Okay, you want me to share, make you host?
Yeah, please.
Host.